Okay.
Okay, this is live. What is this, Lady Ada?
Hey, everybody. Welcome to yet another Show and Tell Hangout. This is our Google Hangout we do every single Wednesday at 7:30 p.m. where you, the audience, you makers, hackers of the world, unite and show us your cool project, what you're working on. We are going to get out of here at 7:55, so we'll have to be very quick this week. Please take 2 minutes to show your project so we can get to everybody. And we're going to start off with NoInPedro.
NoInPedro, what you got going on this week?
There we go. Hey guys. Yeah, this week we have a really simple project. It's sort of a remix of our, there we go. Pedro just got it for me, of our unicorn horn. So I just did a really quick one. This one doesn't have the LED, but I have a hoodie where I did put an LED. And then next week I have this, turn it on. I decided to make the D20 into a kind of mace. So it's like a cosplay prop. It's kind of neat. It kind of resembles, I don't know, like Hawkgirl's mace that she wields around. So it's kind of neat. It has a NeoPixel jewel and an Adafruit trinket, so it's kind of easy. I'm hoping to inspire some cosplayers to start using NeoPixels more. So that's kind of next week's project. That's pretty much it, though. So really quick one this week.
All right, sweet. Thanks for the quick update.
Yeah, thanks, guys.
Okay, Tony D, give us your quick update.
What's up,
Hey, yeah, so real fast, I just wanted to talk about with MicroPython, so on the ESP, you might wonder, how do you use more than 20 kilobytes of data or programs, because that's all you have on the internal file system. It'd be cool if you could plug in a little SD card, and actually you can, so it's super easy with the AdaLogger Shield. This has a micro SD slot and a real-time clock, which you don't have to use, but you just plug this guy right into the board, and then you're ready to go. And so I just did a little guide. If you go to the learning system, so you plug this in, and you can plug an SD card into here and use that to store data or even scripts. Like you can run your main.py file off of here. So cool thing with MicroPython to use SD cards. And this works with other boards. The Pi board, the YPi, they actually have, some of them have built-in SD card slots. But with the ESP, it's just recently added some support. So you can do that in MicroPython and add a little micro SD holder like this. Or there's a breakout in the shop you can wire up for other boards. So check it out if that sounds cool.
All right. Thanks.
And we'll announce this on the show, but if folks want to see all the MicroPython guides, there's a new section on learn.adafruit.com.
Yeah.
You can check out the MicroPython.
Yeah, category. Check it out, right.
Yep.
Yeah, you're a category killer.
All right. Nemesis. Hello, Nemesis. How are you?
Hello. Show off your project in a few minutes.
All right, so I made a bunch of basically Arduino and Raspberry Pi plates, acrylic plates. The first one was just an Arduino plate with acrylic that I laser cut. And then the second one was for the Raspberry Pi Zero, and it's running Tony DeCola's code, example code for the OLED. And then the third one's actually a pretty big one. It's a little testing jig that I made for some boards that I ordered off Oshpark. It's not secured yet. I still need to use a drill press to drill the holes through it. But I made a little Edward Scissorhands cut out with the laser cutter because Halloween's coming up, and I really like Halloween.
That is good and appropriate for a testing
I
jig.
think Edward Scissorhands works all year around, technically. Halloween, you can probably get away with it even more there.
Okay. All right. You want to hold them so close, but not so close that you get like anti-static discharge or something.
Yeah.
Right? Maybe. Okay. All right. Those are some sweet boards.
All right. Thank you so much, Nemesis. Email support@adafruit.com, and there's plenty of room on at least one of those for an as seen on the show and tell sticker.
Yeah, there is.
All right.
Edward
Next,
Tester Hands. Okay.
Amelia. Hello, Amelia. How are you?
Amelia.
Unmute your mic and show us your project.
We can't hear you. No?
I think your mic is still. There you go.
Okay, cool. First time. I made this capelet for Burning Man. Let me try it.
Oh, nice.
It has 20 syllable neopixels on it, and it goes all the way around. And I have a color sensor and a flora. And I just want to show you guys quickly that I use the snaps to connect the ground and the power so that it connects entirely around the entire capelet. And I have a little button and a color sensor, which doesn't work perfectly, but I was able to get about 8 or 9 different modes in my code. So even when the color sensor isn't working perfectly, it just turns things a little pink and red, and everything's cool.
That's super cool.
That's awesome.
That can also be worn besides Burning Man. I think that's perfect attire all year round.
That would be great for weddings.
Yeah.
Bar mitzvahs.
Yes, I like making things look a little bit fancy and, you know, a little bit fun. And next, I really want to put some puffy paint on the inside. The way, I don't know if you guys can see it. It's kind of just a little bit exposed right now, but I like to hide the conductive thread on the underside of the jacket.
Yeah.
Well, that's a cool project. Email support@adafruit.com and you get as seen on the show and tell sticker. Maybe you could put that on the tag on the inside or something like that.
Okay.
Sounds great.
Oh, capelet.
That's super cool.
I just want to prance around.
Yeah.
When you have a capelet, you get to prance.
Saying capelet is just fun.
Capelet.
Yeah.
Capelet.
All right. Thank you so much, Amelia.
All right. Thanks, Amelia.
All right. Next up, Orlando, you said you had some lag on your camera, but do you want to go for it? Okay, Orlando, what you got going on?
So I've been working on PulseSim. So it's an analog recreation of the photoplethysmograph signal. So as I do a lot of things with pulse, right? Because I'm a biomedical engineer. So the idea is you shine a light to your finger, you get the measurement on the photodiode and you plot it. And when you actually do that, you actually get a very characteristic waveform. So what I wanted to do is, the students, I'm a TA for an instrumentation class, and the students were learning about filters and capacitors. And so I just kind of wanted to do a cool project with that. So basically, I used a lot of signal generators, like a triangle wave, a square wave, a sine wave, to recreate the pulse waveform. And so that's kind of what I have going on. So the circuit board is kind of messy. It's just kind of a lot, so I won't show that off. But if we go to the oscilloscope trace, can you guys see that?
Yeah.
You see the purple?
Uh-huh.
So you have a sharp rise here, and that's when systole happens. That's when the ventricles contract and pump blood through your body. And then you have a little secondary peak here that's called the dichrotic notch. The dichrotic notch occurs when the aortic valve closes. It kind of sends a secondary pressure wave throughout the body, and you kind of see that there. So I froze it. As you can see, the dichrotic notch kind of shifts. That's because the frequencies of the sine wave and the other wave aren't exact. But I just want to run it live just real quick, just to see if we can, just so you can see it going. Give it a couple time to adjust there. Right now they're just mixing. But soon here in a sec, you see a sharp rise, and then you have the dichrotic notch, which is secondary, which is, if you look at the photoplethysmograph signal, that's what it looks like. So it's just kind of a fun little project that's using, kind of keeping with my only op amps, no microcontroller, just using a lot of filters to recreate different waveforms.
Really? So it's just a low pass filter or like a notch filter? What are you doing there?
Various assortment of filters. Do I have one more minute?
Yeah, good.
Yeah,
Speed round.
Speed round it.
Yeah.
Share your screen. Entire screen. All right. You guys see that?
Yeah.
All right. So is a sawtooth wave generator. So I create the sawtooth wave generator, then I invert it and put it through a low pass filter. That's how you get the sharp rise. That's how you get this here.
Yeah.
You guys see that?
Uh-huh.
And then the next stage to get a dichrotic notch is a square wave to sine wave converter. So I generate a square wave, then I filter that with a low pass filter to get the sine wave. And then I actually put it through a rectifier circuit just to get half the sine wave. And then I use a signal mixer with just an inverting summer and then another inverting amplifier just to flip it. And that creates what you see here, the combination of the inverted signal
Okay.
and putting it all together.
Okay, cool.
All right.
All right, that's awesome.
Okay, Orlando. Well, you get a sticker, of course. It'll probably be on the oscilloscope.
Yeah.
Adafruit.com, and we'll send one out to you. All right.
Nice,
Next up,
thank
Chris, welcome back to the
Hey,
show and tell.
Christian.
How are you?
Doing great. I just wanted, can you hear me?
Yeah.
Okay. I just wanted to drive by and say that I've released a major update to my infrared code, the library that I built for sending and receiving IR signals using an Arduino. And in the old code, we had a different class for each protocol. It combined together like 7 different protocols. But as we were adding more and more protocols, it was getting too big. It's a lot of projects. You maybe need more than one, but not all of them. So I divided the library up into some different libraries and some header files. And all you have to do is make a list of the protocols. Like each protocol has its own include file. Include the base code, and then you include each of the protocols that you want. And then you include another file that combines it all together automatically. And you can run an application that will receive and send IR signals. And I completely rewrote the user's manual. It's up to 117 pages.
Jeez.
And it documents all the classes and methods and functions. And it includes a real extensive tutorial. And one of the things that people keep asking me is, what if I get a new protocol? How do I write the code for it? So I wrote a big long section on how to implement new protocols, how to research them on the internet, and it should help people contribute new code. And this way, the code won't get bloated as we add new things to it, because you only use the pieces that you really need.
Mm-hmm.
So it's really going to be nice. The next thing that I need to do, the M0 boards, like the M0 family or the Adafruit Zero. And that's going to be tricky because a lot of it's internet driven. It uses hardware timers. And I've already had all the code for AVR. And so now I've got to get through the data sheets and figure out how to put the hardware component stuff.
Mm-hmm. Yeah.
So that's my next project. And then my breakdown on GitHub. There are links on my blog at tech.cyberfrag.com, as you can see in my lower third there. And it's ready to go.
Okay.
Okay.
All right. Well, thank you so much. I also I have the links to it, and I see it on GitHub, and I see that's GPL because GitHub now adds a little license in the corner. Thank you for open sourcing it as well, Chris.
Oh yeah, it's always been open source.
Yeah. All right.
So, all right. That's all.
All right. Thanks so much.
All right, sweet.
Next up, we're going to try to squeeze everyone in. Benji, welcome to the show and tell. Benji, unmute your mic and show us your project.
Hi. Okay. So I've been doing a lot of 3D printing lately, and I really want to say thank you to NoInPedro because I've been watching you guys since the beginning, and amazing stuff. So I modeled in Fusion 360 a mold that I would be able to actually put silicone into. So what I did was I made, this is called a tefillin case, which is basically like straps for Jewish ritual prayer straps. And this is a case for it, and it's completely made out of silicone from Smooth On. And what I did was I actually made a mold, a 3D printed mold that I actually poured it into. This is the base, and it goes in, and it's basically a tongue and groove mold that it goes into. You pour this stuff in here, and I printed it out on my Formlabs, and it came out amazing. And you have like incredible detail here, and I even have the file that I wanted to share. Let's see. Nope. There we go. You see it?
Yeah, there you go.
Yep.
So here we go. Here's the mold. This is like what the actual tefillin was. Then I put the case on top, and then I have the different molds on there that I modeled, and that way I'd be able to actually pour out the silicone mold, and it came out incredible. And I'm very happy with it. And I have a Formlabs. I know NoInPedro really wanted to get a Formlabs or talk to somebody with it, and I'd love to show you guys whatever you want to see about it because I made a lot of stuff with it.
Oh, cool.
Okay.
Exchange information in the comments. This is one of the reasons we do the show and tell, connecting other 3D printer owners with other 3D printer owners. So thanks so much. And of course, you get as seen on the show and tell sticker, email support@adafruit.com, and come back on the show with some of your Formlabs projects that you do, because we don't get a chance to see a lot of printouts.
Thank you.
Yeah.
All right.
All right. We're going to try to squeeze everybody in. So Richard, if you can go, and then Adin, and then C. Scott. So we're going to try to squeeze everybody in. Richard, what you got?
Hey guys, so yeah, what I wanted to show off is really quick. I can't really talk too much about what the finished thing is going to be, but I've been playing around with your guys' rotary encoder, and as you can see, as I spin this little cardboard wheel, the red light tracks with it. It also goes around in a complete circle. What's interesting is I found this encoder library for Arduino, and what it does is it not only tracks the clicking rotations, it also tracks all the steps in between. So I know your guys' rotary encoder has 24 steps and this actually quadruples the number of steps. So it's actually pretty accurate. It uses interrupts, so I was having problems where it was, if you went too fast, it was easily skipping steps. It'll still do that if you really speed it around, but this is actually going to be a very large thing, so I don't think people will be able to spin it too fast. And that's pretty much it. I was going to write just a tiny tutorial on your guys' site with that library, because I noticed there really isn't anything for just this. In the learning guide, there's a bunch of projects that use it, but I found it pretty useful and got some code that worked pretty well.
Okay, I hope it's a Wheel of Fortune game for your cat.
That not quite. Yeah, I can't talk too much about it, but
I'm just saying what I hope it is.
Yeah.
Okay.
All right. Well, thank you so much, Richard. Okay, next up, Itin. How's it going?
Hi. Sorry about some connection issues earlier, but I'm here. So I wanted to do a little follow-up to what I showed last week with the 3D printed bouncy ball project that bounces.
That's pretty good.
Well. I had been printing a third prototype while I was doing that show and tell, and what I figured out is that this one, the second version, was actually in a kind of sweet spot in terms of the density, rigidity, compression, and elasticity that allowed it to bounce really well. Whereas the third revision, which was much less dense and I don't know if you can see that, but much more compressible, did not bounce nearly as well. I also came to a realization that there's a fundamental limit to how consistently bouncy I can make, or how consistently elastic and compressible I can make a 3D printed rubber structure. So here I have two little demo pieces. This one was printed upright, so the layers go this way, and this one was printed flat and the layers go that way. And this one will stretch more before breaking than this one will. And what that means in terms of a ball is when it hits a surface, it compresses vertically and stretches laterally. And so as a result, when it hits a surface that's parallel to its layers, it'll bounce better than if it hits it perpendicular to the layers. So that was something interesting I found. And then I've also been thinking a lot about applications of similar such structures in objects of compliance. And I was thinking a lot about mechanical metamaterials. For example, like a little rubber hinge that varies the density of the rubber in order to flex at a given point. And that's a very linear structure, so you can have a two-dimensional pattern that does that kind of motion. However, if you're making a more complex metamaterial structure, you may want to consider three-dimensional structures that can vary elasticity and compression. It's not something that I've seen a lot of researchers or really anyone look into. And although this is not a metamaterial, as it does not vary the density or elasticity, all it would take was a slight variance in density to make it a three-dimensional metamaterial. That may have gone over a lot of people's heads. I don't know. I don't think I was that great at explaining that.
That's an article about it.
Thanks for the meta material update.
Yeah.
All right.
All the information is in a video, which I'll post down there.
Okay. Well, it's 8 o'clock. You wanna?
Yeah, we gotta go. We're gonna
already
squeeze in
5 minutes.
C. Scott. C. Scott.
Okay, C. Scott, you have 5 seconds.
Hang on. You hear me, guys?
Yeah.
I just want to say real quick that we lost another pioneer in the electronic music world. The picture on the screen, the guy mugging the camera is Don Bupla. He is the what we call the West Coast synthesist mentality. He was not enamored of calling the electronic circuits a synthesizer. He kind of thinks that meant you were trying to emulate real-world sounds. He had a different approach. He had all sorts of tactile controllers and ways of modulating the waveforms because he worked on stuff in the 60s and through last year. The most prolific user of the CMOS 4000 series you would have ever met. He just did all sorts of amazing things. If you want to have some fun, go Google 200 schematics, because that's the stuff he worked on from 1970 to 1976. And since it was before the transconductance amplifier was able to use fractals for all of his voltage and current control modes. But he was a really deep, complex guy, and when you got to know him, his knowledge was just invaluable. So, farewell to another pioneer. That's pretty much it.
Okay, great. Thank you for the
if you send me an email with a link, I'll do up a post on the blog so more folks can.
I posted an in memoriam on the blog for him, so that's not a problem.
Okay.
There's a nice norms. But I know you guys got to go talk about it.
Yeah, we gotta go.
All right. Well, thank you everyone for coming to Show and Tell. Thank you, Richard. Thank you, Orlando. Thank you, NoInPedro. Thank you, Nemesis. Thank you, these guys. Thank you, Chris. Thank you, Benji. Thank you, Amelia. And thank you, Itin. We're here every single week, and we'll see you next week, 7:30 p.m. Eastern Time for another Show and Tell. Thank you, everyone, and email support@adafruit.com if you're on the show and showed something neat. We will send you a sticker.
Okay.
Okay. We'll see everybody on Ask an Engineer in a few moments.
Negative 2 minutes.
Bye-bye.